Good morning, class. I am Xavier Liao, and I'll be presenting on my gram-positive rod Bacillus cereus today and my gram-negative rod Acinetobacter baumannii, and let's get started. So my first bacteria, Bacillus cereus, it's going to be a food poisoning bacteria, and it's normally going to be found in fried rice, refried beans, milk, under heat lamps where it's kept warm enough for consumption, but not warm enough to be antibacterial. And what Bacillus cereus does is it'll give you diarrheal enterotoxins, or it'll give you emetic vomiting toxins. And what you'll get from that is Bacillus cereus gastroenteritis, and this is more commonly known as fried rice syndrome, which is hard to differentiate from the other food poisonings like Clostridium perfringens, where you're going to also have diarrhea, vomiting, and it's only going to last for 1 or 2 days. And this, along with the other food poisonings, as long as they're lasting less than that 48-hour period, people are often not going to report it. I would not report it to a doctor if I was only sick for 48 hours because most of the time people will just get water and rest. So it's not a major disease. And then my scientific article was about these scientists who went up to New York. They were getting a lot of 179 cases of food poisoning were reported to them, and so they inspected 33 different isolates of beans in that store, and were actually able to 100% trace back a contamination error in the factory which was supplying all these beans. And the scientists hypothesized that there were actually a much larger number of unreported cases of food poisoning because these beans had enough Bacillus cereus to make a lot of people sick. And that was the scientific article. My next bacteria is going to be Acinetobacter baumannii, more commonly known as Iraqi-bacter because it was acquired in hospitals in Iraq. And so what is Acinetobacter baumannii? It's going to be primarily a nosocomial infection. We originally thought you could find it in the soil because we would go around the IED explosions and we would find it in the soil, but that was actually inconsistent and unrepeatable. And we pretty much now almost exclusively collect it from hospital specimens, catheters, ventilators, stethoscopes, door handles, and pretty much the natural habitat of Acinetobacter baumannii for all practical applications, the hospital. And to add on to that, because its natural habitat is the hospital, it's an escape bacteria, which are the highly antibiotic drug-resistant bacteria. That's going to include Enterococcus, Staphylococcus, Klebsiella, Acinetobacter, Pseudomonas, Enterobacter, Escherichia. All those are going to have high antibiotic drug resistance and going to cause a lot of complications for patients. And so what'll happen is, you'll have a soldier, he'll get injured, he'll get shot, or he'll have an open wound or something, and they'll put him in that first hospital and stabilize him. And then if he's okay, they'll take care of him there. But a lot of time, he'll need to be sent to another hospital, taking care of some more, and even a third or a fourth. And this regimented plan was kind of first coming into theory right when we were doing the Iraq War, and it was good in theory to keep people safe, but it was not good in practice because as you transfer these injured people from hospital to hospital, they can acquire a nosocomial infection at each hospital and they can spread it to other people. And so even though it was supposed to make people safer, it was actually hurting people more. And what you'll get from these escape bacteria is most notably going to be hospital-acquired pneumonia, but it can also give you stuff like meningitis or UTIs or bloodstream infections. But it's mainly just going to be pneumonia. And then the scientific article I chose was scientists went to a American hospital in Baghdad, and they took 121 different objects, computer mouses, door handles, catheters, ventilators, and they cultured all of them, and they found a twofold discovery. First off, they did not expect A. baumannii to be the most common of all the escape bacteria. So all the escape bacteria had around 5 isolates they could find on those 121, but A. baumannii had 21, and they also didn't expect A. baumannii to have such high resistance to all these antibiotics. They had 100% resistance to Cetraxil, to Levaquin, to Prismol, and that's not even to mention all the other things that had 95% resistance to or 90% resistance to. Kind of, again, beating down the point that this is a highly antibiotic-resistant bacteria, and we need to be careful with how we treat it so that it successfully helps the patient and also does not continue to promote this high antibiotic drug resistance strains. And thank you so much for listening to my lecture.